Now let's talk about converting standard notation to scientific notation. And so we're just going in the opposite direction. Let's say we have a number, say 250, and we want to convert that to scientific notation. Remember, the scientific, or the best way to do it, or the correct way to do it, is to have a number that is equal to or greater than 1 but less than 10 as your first digit, so that's going to be 2.5. Now you don't have to put the 0 after the 5 here. You can if you want, but it is not necessary. Now, this here is, if we're going to go from 250 to 2.5, we want to basically count how many times, because really this is the decimal, how many times are we moving, how many places are we moving to get to 2.5? See what I did there? So 1, 2. Okay, so that's going to be times 2 to the second power. 2.5 times 10 to the second power equals 250. And if you want to do just a little double checking, you could do that. You got 2.5 times 2, we're going to move it 2 places to the right, so 1, 2, and so that's going to give you 250, and that's what you started with here. So this would be correct. Let's do another one. Let's say we have 14,864. Okay, again, scientific notation, it's got to be equal to or greater than 1 but less than 10 for our first digit, so it's going to be 1.4864. Everything else follows. Okay, now we want to know what we're going to multiply, what power of 10 are we going to multiply by. So again, if this is our decimal, and we don't usually write a decimal after the last digit, but it's there, so we're basically saying how many places do we need to go in this direction to tell us what our exponent is going to be over here. And so if we do that, we go 1, 2, 3, 4. This is going to be a 4. Okay, so we basically went from 14,864 to 1.4864 times 10 to the 4th power. Let's do another. Let's say we've got 7,045,000. Okay, so again we're going to go 7.045. We don't need to put the zeros after that last digit. That's not a 0. But we want to know how many places we're moving from here, not from the 5. So we're going to go 1, 2, 3, 4, 5, 6. So that's 10 times 10 to the 6th power. Okay, let's do some numbers that will give us a negative exponent. So 4/10, and we want to write that in scientific. So this is standard form or notation, and we want to go to scientific notation. Okay, so because this is a number that's less than 1, we want to make this into a number that is equal to or greater than 1 but less than 10, so that's going to be 4 times 10, and basically the decimal's right here. Okay, alright, so what we've done is we've moved it 1 place, but we're going to move it in the negative direction. So 4 times 10 to the negative 1. Let's do another. Let's go to hundredths. So say we have 15 hundredths. That's going to be 1.5, and we're moving this 1.5 over 1 place, so it'd be 10 to the negative 1. Let's do 362 thousandths, okay? So we want to go, again, we want to make this 3.62 times 10 to the negative 1. That's going to bring that over 1, okay? We'll do that. Now let's go ahead and make some other types of numbers. Say we've got a bunch of zeros after the decimal. We'll go like that. Okay, so that's 3 10,000ths. Tenths, hundredths, thousands, 10,000ths. So again, we have to write it as 3.0 or 3 times 10, and we're going to go over 1, 2, 3, 4, so negative 4. With these decimal numbers, your exponent in your scientific notation form is going to be a negative exponent. Let's do another. Let's say we have 0.00000058. That's a lot of zeros. So again, we're going to write it as 5.8, and so what we want, this is our target here. How many spaces do we need to, or how many places do we need to move that decimal to get to this point here? So we're going to go 1, 2, 3, 4, 5, 6, 7. So times 10 to the negative 7th.